here's a story about making renewable natural gas from forest waste. Vancouver-based energy clean technology startup is turning forestry waste into renewable natural gas. This pilot project has already been powering Edmonton homes for 6 months. We are joined now by Edson Ng, principal at G4 Insights. It's great to see you. Just talk about the technology. Apparently this idea of turning wood waste into synthetic natural gas is not new, but you're doing something different. Can you tell us about that?
Thanks, Andrew. The idea of converting wood waste into renewable natural gas has been worked on for probably over 20 years. But the conventional approach is to first convert it using a gasification process into something called syngas, and then to methanate that, which is methane is natural gas. We found that that would be very problematic when we first looked at the technologies available, and we found an alternative route which avoids a lot of the problems that they had with gasification, and that is called fast pyrolysis. The idea is what we take forestry residues, so that's the tops, it's the branches, it's the sawmill waste. And the first step is to grind it up into 5mm particles. From there, we flash heat it, and we create something called pyrolysis gas. So it's not syngas, but it's pyrolysis gas. Think of that as fragments of biomass molecules. The next step is to put that gas across a catalyst with hydrogen present, and that combination will form methane. The methane is then purified and injected into the natural gas grid for distribution to any natural gas end use.
Now, you've shown it works on a small scale, but what about the gas that's produced? Is it more costly than gas that you just take out of the ground in the normal way?
It is more expensive, but it's well supported by the market for renewable natural gas, much in a way that renewable electricity is at a premium price to, say, coal-powered or some of the ethanol blends or biodiesel may be more expensive than the stuff coming out of the ground as well. Within a market for renewable natural gas is very competitive, and the main competitors are things like landfill gas upgrading and anaerobic digesters, where you're capturing methane and upgrading that for injection in a pipeline.
You've shown it works on a small scale. You worked with ATCO, the utility giant, and Edmonton homes and businesses have been using your gas.
Yeah, that's right. It's a small amount, and the idea is to scale up to something that matches, say, a sawmill operation where the residue from normal harvesting activity would support a commercial-sized plant, and something at that scale would produce enough gas, probably about 10,000 gigajoules a day, which coming from about 750 dry tons of residue. And that amount of gas would support up to 45,000 Albertan homes.
So let me get that right. So one sawmill, we're talking about something like 750 tons of waste a day.
Of waste a day, correct.
Yeah.
And then the output from that is 10,000 gigajoules of gas a day from that plant. And that's enough to support about 45,000 Albertan homes.
Now, what about if you just burn this wood waste or turn it into pellets, for example, like they're doing in Europe? Which method would produce the most emissions?
It's a very interesting point, is that we believe that the pellet industry would be a target for us, because we could produce renewable natural gas and liquefy the natural gas and actually send it over to Europe and have better power production, because you're using high efficiency natural gas turbines as opposed to converted coal plants, which are low power efficiency. And we would get better utilization of biomass, plus lower costs overall for the energy. So we believe this is the next evolution of where pellets have had its play for the last 30 years. The next generation is renewable natural gas from the same fiber.
Would your thing work in an isolated community? Could they just set up a standalone plant from local wood waste to make natural gas to heat their homes?
Absolutely. A lot of the remote communities, especially in forested areas or even mining sites, are bringing in diesel, kerosene. A lot of these fuels are brought in by air or trucked in. It's very expensive, when in fact you could produce natural gas locally with local labor, and you could use that natural gas for power generation, you could use it for transportation fuel, and also for space heating. So it's ideal for a lot of these remote sites.
And even a play, we've less than a minute, I'm sorry. Would you need experts on site though, or could you build a plant that would be more or less just self-running with minimal maintenance? Sorry, we've less than a minute.
Sure, it's like a small refinery, so you do need some skill sets to operate equipment, but certainly the collection and processing of the biomass going into the system, where the bulk of the jobs are, that would be perfect for the local skill sets.
That's fascinating. Edson, thank you very much for joining us.
Thank you, Andrew.
Edson Ng, Principal at G4 Insights.